So Edgar, in this dichotomy, and so in the Newtonian physical world, and then in the Descartes, I think therefore I am in the subjective world, there's a science and a philosophy, and the Newton science was good enough to get you to the moon and back.
Isaac did that.
and it gets spacecraft to Mars so we can explore the planet. So there's a science to the old view that changed for you. Is there a science to your new understanding of the universe?
Yes. It has always been true that Newtonian science simply failed to, it didn't address inner experience and consciousness and mental phenomena. Yeah. That was a no-no. That was the other side of the street. But with the beginning of the 20th century, and Einstein's famous paper in 1905 began the real inquiry that suggested light had two characteristics, both particle and wave characteristic. Mm-hmm. And we later very quickly discovered that all matter at that level has wave and particle characteristic. And that was the beginning of quantum mechanics. Now, quantum mechanics has not really been applied to mind the stuff in all these years. And largely because that was a theological issue. But it turns out that if we use quantum mechanics to start to understand some of these mystical type issues, or I do not like the word, but parapsychological type issues, we make great progress. Okay. And that's what has happened here in the last 25 to 30 years.
Edgar, how would you define quantum?
Okay, a quantum merely means a little packet of something, an amount.
Okay.
And so light, for example, considered as photons, the smallest particle of light, which is based upon the energy content, it's called a quantum.
Okay.
And so the whole study of quantum mechanics is a study of small particles.
Okay, that makes it simple.
It makes it very simple. But what makes it different from Newtonian classical mechanics are several properties that are called entanglement, coherence, nonlocality, and resonance. Now, you find resonance in classical mechanics, but you also have it in quantum mechanics. Now, let's define those terms.
Okay.
Entanglement means that if subatomic particles are ever in a process together and they go apart from the universe, from each other, they maintain a correlation so that if something happens to this one instantly reacts to it, or we say, quote, unquote, instantly knows what's happening.
And does it matter how far apart they are?
It does not matter, according to the best theory. It doesn't matter how far. They can go across the universe from each other.
Okay. Have there been any tests?
Oh, yes. This entanglement, and non-locality is the description of the fact that they know instantaneously regardless of how far they are apart, which truly is an enigma for classical mechanics and general relativity and Einstein's special relativity. So here's a conundrum here. But it has been demonstrated, as far as we can reach out, that it's true, that non-locality is a property of nature at that level. And coherence, to use another word, coherence, it means that the light waveforms are together. Okay. In other words, I like to use the concept, it's the difference between combed hair and uncombed hair.
That's a good way to think of it.
Everywhere. And light, we say polarized light, is coherent. The waveforms are all structured. So these are the properties of matter at this subatomic level. And for 80 years, we have been taught, and it's in the dogma, well, that's all very well and good, but it doesn't have anything to do with our scale size of things. It doesn't apply to us.
In the macro world.
In the macro world of reality. And as it turns out, that's dead wrong. It does apply to us.
Okay.
And the information from that world is available under certain conditions, and it's generally available through a process of resonance. Now, we can think of resonance to get that idea across as if I pluck a violin string over here, and a similarly tuned violin string across the room starts to vibrate and make a sound, which we all know happens.
Yes.
That's resonance. So we see this as one of the four properties, fundamental properties at the quantum level that are quite germane to our understanding, new understanding of these type of phenomena.
Does this new science, does it in any way help resolve that dichotomy that we were talking about between the outer objective and the inner subjective?
Well, it is precisely the way quantum mechanics was initially formulated, that knowing was what seemed to bring reality at that level into existence. That was one of the earliest interpretations, was that the interaction of mind and matter came together, and quantum mechanics started to formulate that in the sense that we can formulate things in such a way that they don't become real until they're known.
Right.
But it's still true that mind-matter comes together, and we can study some of these powerful aspects of bio-nature and mind and consciousness using quantum mechanics. For example, one can ask the question why we are told and taught that the primary chemicals in our body is carbon.
Okay.
So carbon, hydrogen, and oxygen and nitrogen are fundamental to the bioprocess. Well, one must ask then, what is the difference between the carbon, hydrogen, nitrogen, oxygen in this biomatter and that which you just find in inanimate nature?
Okay.
Well, it is because it is entangled, coherent, non-local, and its information flows by being resonant. So the body is
So they really all play into it.
It all plays together, and the ancient dogma that only pertains to subatomic matter is just dead wrong.
Okay.
We have shown in modern times.
It's really throughout nature.
All throughout nature,
Yeah.
that nature is interconnected in this way.
Yeah.
What do you think the best evidence is about that non-locality is real?
There have been hundreds and hundreds of experiments done with individuals in a shielded room that where electromagnetic signals cannot penetrate.
Okay.
But the most powerful experiments that have been done that way is if you hook two people who are simpatico up to EEG machines, but keep them separated from each other, and then tell one of them to think about the other, even though they're isolated electromagnetically, their brain waves go in sync. And so that is one of the more powerful bits of evidence.
And that would be kind of like a mother who knows her baby in another room is not all right, even though there's no sound.
That's right.
Is there a mechanism that accounts for this?
That is the great enigma that we still don't quite know how information propagates. Einstein's special relativity says that information, nor anything else for that matter, cannot be propagated faster than the speed of light. But non-locality says it's an instantaneous propagation.
You just said that earlier.
But we don't quite understand the mechanism. Now there's a lot of physics that goes into this. The primary issue is something called a zero-point energy field, which seems to be the propagator for this type of information. A zero-point energy field is an invention or a discovery, if you will, or a renaming in the 20th century of what used to be called the ether.
Okay.
That the ether was thought to pervade all space. And if light was a wave, what did it wave in?
Oh, yes.
So the ether was thought to be the substance in space that light waved in. But then the Michelson-Morley experiment in the late 1900s did an experiment that measured the speed of light in different parts of the Earth orbit and discovered it didn't matter, that the speed of light was the same regardless of where you measured it. And the natural conclusion of that there is no ether. Space is totally empty, because otherwise there would be a Doppler effect.
Okay.
It turns out that wasn't true. That was a wrong interpretation, that space isn't empty. It's filled with quantum fluctuations. And that's borne out by several different types of experiments and studies. So we now call that the zero-point energy field.
Okay.
And it means that the basic concept here is that we've known forever, since quantum mechanics, that matter, when in its natural state, is emitting and reabsorbing energy continuously. And even if you take it down to absolute 0 degrees Kelvin, which it's supposed to be inert at that point, and even though matter changes properties, it still emits and reabsorbs energy at 0 degrees Kelvin.
Okay.
That's why it's called a zero-point energy field.
Okay.
And since space generally is at 0 degrees Kelvin, unless you capture some light beams, and it is presumed that the zero-point energy field pervades all space.